is quite literally made out of rock. And so is much of civilization. At Vulcan Materials Quarry in Manassas, Virginia, ton after ton of this basic building block is blasted out of the Earth's surface and processed into aggregates, suitable for everything from roadways to prefab concrete walls.
Most of it serves the local market for concrete, asphalt, cinder blocks. We use it for road base, for beds, for bridge building, for driveways for people's houses. The industry says that for every person in the area, you have to supply 10 to 12 tons of rock per year.
But it's no mean feat turning 4-foot-wide volcanic diabase boulders into tiny uniform stones. It's a job that calls for some very big machines, like the one housed in this 10-story structure, built to deal with the fact that rock doesn't come in convenient sizes. Rock crushers.
The Metso Minerals 4265 Superior Gyratory Crusher. Total weight, 264,000 pounds. Height, 10 stories. Motor, 500 horsepower electric. Diet, 2,557 tons of stone per hour.
The 4265 is known as a gyratory crusher because of the motion that actually does the crushing. The relentless back and forth gyration that compresses rock against the chamber walls.
To give you a visualization, this crusher is just a giant mechanicalized nut cracker. That's the same principle. When you have two surfaces, hard surfaces closing together with a soft surface in the center. In this case, believe it or not, the rock is a soft surface. So it's two mechanically advantaged metal pieces coming together and compressing that rock, and the rock breaks down to a smaller size.
The process begins in the control booth that sits atop the crusher, where the operator has a front and center view of each 100-ton load as it's fed into the crusher's mouth. Water spray keeps the dust constantly under control.
All of our crushers are designed to work at a choke-fed position. It's because the rocks on top of the crusher help push down the rocks through the crushing chamber, and the rocks will actually crush against themselves. That's called rock-and-rock comminution, and it actually does a better job of crushing size materials.
Primary crushers such as this one can accept rocks up to 3.5 feet in diameter. Operator Pete Hupp uses a hydraulic hammer to reduce anything bigger. At the core of the crusher is a solid steel shaft, up to 26 feet long. The cone-shaped mantle threaded to the shaft provides the crushing surface. The shaft and mantle were each forged as a single piece of steel.
The mantle itself, the main shaft, weighs in excess of 52,000 pounds.
This giant nutcracker is powered by a 500 horsepower electric motor. The motor drives a horizontal pinion shaft connected to a large crown gear, which causes the giant vertical main shaft to spin. The main shaft sits in a housing known as an eccentric due to its asymmetrical shape. As the main shaft rotates, it shoves the crushing mantle back and forth in an eccentric pattern, 170 times per minute against the chamber walls. The rocks don't stand a chance. The crushing mantle would be nothing without ultra-strong chamber walls.
The castings on this machine are cast steel. They're heavy ribbed cast steel, very strong chambers. They are wear-plated, protected with either a manganese concaves or a steel alloy concaves.
2 stories down from the control room, the crushing is in full swing.
Right now you're hearing the rocks being crushed against this outer chamber here, which is the top shell. This section right here is the top shell with the heavy rib that support all the crushing forces. From this joint below, it's called the bottom shell, and that's where all the mechanics of the crusher are. The eccentric bushing, the bottom shell bushing, the eccentric, and below that is a main shaft position system, which raises and lowers the main shaft.
The greatly reduced stone emerges below.
You can see the size difference between the back of the truck and what's coming off that conveyor. That's how much it reduces that rock through that first stage.
This highly efficient method, known as compression crushing, has played a key role in history.
The first patented compression crusher was developed by a gentleman by the name of Eli Whitney Blake. Back in 1858, he held his first patent. He was actually the nephew of Eli Whitney, the inventor of the cotton gin. Eli Whitney Blake was challenged by the town commissioners to develop a crusher or some type of device to reduce stone in order to make macadam for a 2-mile stretch of highway. It took them 5 years to create this machine, which features one stationary jaw die, one opposing, turned in an eccentric motion. This became the first compression crushing, and the Blake-style crusher is still in production today.
In the late 19th century, rock crushers would prove invaluable in laying roads across a growing nation and in extracting precious metals out of giant blocks of stone. Nevada's legendary Comstock lode pumped out wealth at an unprecedented rate, thanks to mechanical crushers. A major innovation in giant crushing machines came in the 1920s with the Simon's type, or cone crusher. Unlike a traditional gyratory crusher, the shaft on a cone crusher isn't supported at the top. This gives the crushing mantle more freedom of movement and twice as much horizontal throw. Today, Metso Minerals makes the world's largest cone crusher, a 340,000-pound, 1,000-horsepower behemoth known as the MP1000, which also happens to reside at Vulcan's Manassas, Virginia quarry.
The MP1000, the largest machine of its type ever built, the most highly technically advanced machine, and it's exciting to see.
The MP1000 is the secondary crusher at the quarry. The stone already reduced by the gyratory has made its journey over on a conveyor belt and awaits a further crushing. The rapid throw of the mantle pulverizes the rock against the steel cone-shaped bowl liner.
This is a bowl liner. This bowl liner fits into the upper portion of the machine. The bowl liner is a manganese wear surface. This wear surface is actually what the rock is impacting against. As the machine gyrates from one motion to another, as the material passes through, the rock then is reduced, falls through, and then moves to the opposing side.
After exiting the mighty MP1000, the stone can move to a third or even fourth crusher, depending on the desired product. With multiple crushers and screens, Vulcan Materials produces crushed stone ranging from large rocks suitable for flood control to sand that might end up in concrete.